We are given a directed graph with edge weights that may be negative, and a source vertex. Our goal is the shortest path distance from that source to every other vertex, or, if a negative cycle is reachable from the source, to recognize that some shortest paths are not well defined. Bellman works toward that goal by running v-1 rounds. Each round relaxes every edge once, so distances improve hop by hop. One more round over all edges checks whether any distance can still improve, which would mean a reachable negative cycle. In the example graph, A starts at 0. The edge A to B with weight -1 sets B to -1. The path A to C through B gives -1 plus 3 equals 2, better than the direct edge 4. Continuing B to C to D gives 2 plus -3 equals -1 for D. The green edges trace that shortest path tree from A. For vertices A through D with source A. The picture shows directed edges and weights, including -1s. The row labeled dist is the best shortest distance estimate from A to each vertex so far. It starts at 0 on A and infinity elsewhere. We do not use a priority queue or min heap. The algorithm only needs this graph, the dist row, and repeated full scans of every edge. The counter marks which pass we are in. We will run v-1 full passes, and each pass walks every edge once in a fixed order using the relaxation rule at the bottom. Follow the first pass edge by edge as the estimates tighten. Pass 1 of 3. Relax from A to B, weight -1. We improve distance to B from infinity to -1. Relax from A to C, weight 4. We improve distance to C from infinity to 4. Relax from B to C, weight 3. We improve distance to C from 4 to 2. Relax from B to D, weight 2. We improve distance to D from infinity to 1. Relax from C to D, weight -3. We improve distance to D from 1 to -1. Pass 2 of 3. Relax from A to B, weight -1. Distance to B is -1. 0 plus -1 equals -1, which is not strictly less, so no update. Relax from A to C, weight 4. Distance to C is 2, 0 plus 4 equals 4, which is not strictly less, so no update. Relax from B to C, weight 3. Distance to C is 2, -1 plus 3 equals 2, which is not strictly less, so no update. Relax from B to D, weight 2. Distance to D is -1, -1 plus 2 equals 1, which is not strictly less, so no update. Relax from C to D, weight -3. Distance to D is -1, 2 plus -3 equals -1, which is not strictly less, so no update. For the third and final pass we again walk every edge in the same order and relax each one. Distances are already as small as they can get on this graph, so the dist row will stay unchanged while we finish the scan. All 3 passes are done. The green edges show one shortest path tree from A. The dist row is the final answer for this graph. Bellman runs v-1 rounds, and each round relaxes every edge once, so that is order v times e work. One more linear scan over edges can detect a reachable negative cycle. Space is order v for the distance array and optionally the parent array. There is no priority queue. We initialize the source distance to 0 and every other vertex to infinity. The graph is given as an adjacency list. We will output the dist array and optionally a parent array to rebuild shortest paths. The outer loop runs v-1 times. Each inner loop walks every directed edge and relaxes it, if we can shorten the path to V through U, we update dist of V and optionally record parent of V. After those passes, one more scan over all edges checks whether any relaxation is still possible. If so, a negative cycle reachable from the source exists. Otherwise we return the dist array.